Good day, ladies and gentlemen. This is Sarel van Grenen, aka Mr. VG, and I am excited to be here today. This is now our first of a series of live videos that I'm going to be tackling grade 11 mathematics. And I'm going to be starting with my favorite section in grade 11 mathematics, except maybe for Euclidean, but I know I'm special with that. I'm going to start today with functions and graphs. Now, today's session, I planned something very, very special for all of us wonderful people who are looking forward to exam preparation coming up soon. Hopefully, your exam preparation has already started. Now, let me just quickly say the following. If you are new to this and you don't really understand how this happens, what I'm going to do is, in this next 45 minutes to an hour long, I am going to work through some old exam questions. So in other words, questions you might be expecting in this upcoming exam. Now, I am happy that you decided to join me here today. My name is Sarel van Grenen, aka Mr. VG. Please buckle up, get yourself ready, and if you don't have something, get a pen and a piece of paper ready. A short little note for those of you tuning in for the first time. Feel free to hit the pause button at any time to try the sums yourself and then look at the way that I am going to do it. This video will also be made available afterwards on the Junior Taki YouTube channel supported by Investec, and we are going to make this available for everyone. So in the description later on tonight and in the recorded video, I will put up some amazing, fantastic worksheets and memos, one worksheet with a memo, that's available for you to go and practice functions and graphs. So let me not waste your time with my beautiful voice, and let's dig in to our first little question. Now, this question, ladies and gentlemen, was kind of sort of in one of my previous exams, and I adjusted it a little bit to make it more interesting. Now, the moment that I make an exam question interesting is the moment you start running to their heels. But let's quickly look at this question. So the given sketch is for the functions f of x equal to 2x squared plus ax plus b, so a parabola, and g of x equal to mx plus k. Now, before I answer any questions, before I look at the question, what I would like to first of all do is I want to analyze, get as much info from what has been given. Now, what has been given is that I have a parabola because it is an x square. Let me do that better. There's an x square there. Now, important, it is a smiling parabola because of the a value, which is 2, which of course is greater than 0. Now, that little bit of information I am definitely going to use, but you will see when and where. Let's quickly look at the first question. Okay? Oh, sorry, before I get to the first question, I haven't actually analyzed the straight line. Now, what do I know about the straight line? I can actually just read off from looking at the graph. Now, the m value must be larger than 0 because it is sloping upwards. And I know that the c value must also be positive because of where it cuts the y-axis. That we are going to use as a test later on to make sure we did not, mess up somewhere in this question. So let's quickly have a look at the first question. It says determine the values of a and b if a is -1 and 0 and b is 5, 0. In other words, the x-intercepts. Okay? I know it's maybe a bit small on your screen. Maybe zoom in a bit. But that's your two x-intercepts, at -1 and 5. So what are they actually asking you? They are actually asking you for the equation of fx. Now remember, when you've got the equation of a parabola, ladies and gentlemen, I have two options. Either they're giving me the turning point, where I go towards the equation y equal to a, x minus p squared plus q, or secondly, they give me the x-intercepts, where I go towards the formula a, x minus x1 and x minus x2, or hope and pray you don't get this one, but thirdly, if they give you, I'm going to put this in inverted commas, random points. Now I'm saying random points because they're not usually so random, but there you have to substitute in all three sets of coordinates and solve simultaneously. Now I have seen it being asked literally once in the past 15 or 20 years, and that was in the matric final exam. I'm going to see if I can find that one for you. But if I'm preparing for an exam, I don't worry too much about the third one. I worry more about the type 1 and type 2. Now in our one, they gave us the x-intercept. So I'm going to go towards that formula. So I'm going to start by going y equal to a, x minus x1, x minus x2. Now x1 and x2 was actually given to me, so I am going to substitute them in. The two x-intercepts, the one is at -1 and the other one is at +5. Okay? Now, at this moment of time, my grade 11s start freaking out just a little bit, because to calculate a, we usually have to substitute a set of coordinates in, because I cannot read it off from the graph. So now what? What do I do now? Okay, please don't freak out. Please don't freak out. Here's the beautiful thing, and please understand. That a that's in front of the x squared is actually the same a that's in front of the brackets. So actually, I'm sitting with 2, x plus 1, x minus 5. Okay, whoa, sir, whoa, just stop the bus. What? Remember, the a in front of the brackets is the a that's in front of the x squared. And if I look at the equation that's given to me, that is 2. So in other words, they actually gave me a. So you didn't have to substitute a coordinate in. Be careful. We as teachers can be very sneaky in the exams. Now, I'm not done with the question because I still need to multiply out. Now, just a little bit of a side note. Do not confuse the a in front of the bracket with the a that is there in the equation, the one that I asked you to calculate. They are not the same a. That a that is given to me there could have been any variable. It could have been an m, a p, a q, an alpha, anything. So please understand that the a in the formula, the standard formula, that is set in stone. That is the coefficient of x squared. So don't confuse the two, please. So let's quickly now multiply out my brackets. So x squared minus 4x minus 5. And if I distribute the 2 in, 2x squared minus 8x minus 10. Perfect. I'm happy. Just a quick little tip. Do not forget to test. In other words, small little things that just point us towards whether we are going right or wrong. What can I now read off from this equation? The graph must be smiling. Great, it is. The y-intercept is at negative 10. And that makes sense because if I look at my sketch, that e value is at negative 10. Perfect. That means that I have a good idea that I'm going in the right direction. Perfect. I love this. So now I'm ready to move on to the next question. Please remember, if I'm going over something too quickly for you, hit the pause button. You can always rewind, try it yourself, go over it again, sleep on it, come back to the video tomorrow. But please stick with me, ladies and gentlemen. We're going to have fun the rest of the night as well. Now it says there, it is further given that OD, so that length there, is 1/5 of OE. So if OE is 10 units, that means that is 2 units. Why? Because it's 1/5 of 10. That means D's coordinates is x is 0. I almost made a very silly mistake there. And y is 2. Okay? Now, again, this is why it's important. The moment you do something in like 2.1, you can actually look at your sketch and write it in, and from now on it is assumed that that's what's going to happen. My mouth is getting stuck here on my tongue. Let's quickly have a look now at the next question. Question 2.2. Question 2.2 asks us to determine the values for m and k. Now, m and k again is a gradient and k is the y-intercept. So automatically I have that k is equal to 2 because that's a y-intercept. Now you can go, because I know a lot of you guys are going, woo, so I know how to do a gradient, I know how to do a gradient. I'm going to do something different just because I can. If I look at y equal to mx plus 2, which is now the equation I'm sitting with, to get m, I can simply substitute the other coordinate that I have, which is negative 1, 0. If I substitute this in, I get y is 0, x is negative 1. Now I can simply calculate m without using the gradient formula. Would it be wrong to use the gradient formula? No, but I'm trying to extend you past just what you are used to. The regular wrote 1, 2, 3, I do 1, I do 2, I do 3, and books, I'm done. No, I want you to think about different ways of doing it. Especially if you are an 80 or 90%, ladies and gents, I encourage you, always find 2 or 3 different ways to solve a problem, because you never know. Maybe in an exam, you will need a backup plan because your usual plan doesn't work out. If you are a 40 to 60%, hey, stick to what you're used to. Please, make sure you do those basics right. But your 80s, your 70s, 80s, and 90s, you have to look at different options so that you are prepared for what's coming. Now let me quickly solve m. So I have negative 2 equal to negative m, divide by, not 2, by negative 1. Therefore, m is 2. Oh my goodness, that's cool. Yes, it works out because it is a positive gradient. So in other words, I now have g of x here being 2x plus 2, and it makes sense because the graph must be sloping upwards. K is 2, makes sense because the y value is positive. Now let's quickly, ladies and gents, go on to the next question. Question 2.2. Given that m is equal to 2 and k is 2, yes, I've done it correctly. I've done it correctly. The reason why they actually gave this to you, remember, very simple, is because you need it for answering question 2.3. And let's say you didn't get m to be 2 or k equal to 2. From 2.3, use those values given to you. Please, ladies and gents, don't use your own values because it won't work out so well. So let's now go and have a look at question 2.3. I'm just going to go over to a new slide. If you're still writing down, hit the pause button, and then when you are ready, you can play on. If I look now at the question 2.3, given that m is equal to 2 and k is equal to 2, determine the coordinates of C, the points of intersection. Now, I know for some of you, you go, oh, so this is easy. I can do this with my eyes closed. Well, go for it. I'm doing this to make sure that I've got all the bases covered with you. So let's quickly have a look at what I'm trying to do. Point C, I want to do fx equal to gx. So in other words, f of x is 2x squared minus 4x. Let me just quickly go back. Am I right? 2x squared. Oh, no, I'm not right. Minus 8x. So let me quickly correct that. Minus 10. And we put this equal to 2x plus 2. Now, if I solve this equation, it is quadratic. So I get it equal to 0. Minus 10x minus 12 equal to 0. Remember, you are allowed to use the quadratic formula if you want to. I'm just going to skip a step for the sake of making it easy. So you factorize this into 2 brackets. I'm sorry if I'm skipping a step and you are getting a bit freaked out. X minus 6, x plus 1. Please try it yourself first. Therefore, x is equal to 6 or x is equal to negative 1. For what we are looking, negative 1 is not applicable. Huh? Sir, what do you mean? Remember, I'm looking for C. At C, the x value, let me do a nice line there, is positive. So there is 6. A is at negative 1. So I'm not going to look at 6. That's why I throw away negative 1, because it doesn't fit where I'm going. Now, to get the y value, remember we said coordinates, so I need both x and y. I'm going to substitute into the easiest one, which is g of x. So I'm going to make x 6. So this is 2 times 6 plus 2. And this gives me 14. So please remember to finish off the sum. 6, 14. No issues. Perfect. 100%. I like it. Does it make sense? Yes, because the y value must be positive. And it must be higher than 2, because at D, the y value is 2. So it must be a lot higher than 2. So it makes sense. Always check your answer. Let's quickly look at 2.4. Question 2.4 says, determine the x value where fg's length is a maximum. Now, the moment I see this from all my students, even my matric students, I say to them, the moment you see FG or PQ, and it's the distance between 2 graphs, 2 vertically above each other. So in other words, F and G has to be vertically above each other. I simply take the top graph minus the bottom graph. In other words, I'm going to take the equation of gx and I'm going to subtract the parabola, because the top graph is gx. It's a straight line. Excuse me. So g of x is equal to 2x plus 2 minus f of x is 2x squared minus 8x minus 10. If I simplify this, it becomes negative 2x squared minus 10x plus 12. You can remove the brackets yourself, distribute the negative in, add the like terms. And now I'm going to divide straight through by negative 2. And then I'm going to get x squared plus 5x minus 6. Oh, if you do this, you get nothing further. But so what do you mean? Ladies and gents, be careful. This equation is not equal to 0. No, it's equal to fg. You are not allowed to divide by anything because it's not equal to 0. You've got nothing to solve. Please stop. Don't do that. I purposefully just put you on the wrong track. Excuse me for that, but I just had to do it because a lot of my students go on autopilot. Oh, I see an equation, I solve, I just go and I go without thinking. So please be careful. It's not equal to 0, it's equal to fg. Now we need to look at what is the actual question. The actual question is, where is fg's length a maximum? Now, a maximum, oh, I so wish you guys were in grade 12 already. Then I teach you calculus at this moment. But we have to now analyze. Fg is a parabola. An upside down parabola because of the negative 2. Where would this graph be at a maximum? At the turning point. So in other words, they're actually asking me for the turning point of fg. So in other words, I need to get that axis of symmetry. X equal to negative b over 2a. Now b, in this case, is negative 10, so it's negative 10 over 2 times by a, and a is negative 2. So in other words, x is 10 over 4, which is 2,5. Not unit, sorry. Now, the question was, where is fg at a maximum? At x equal to 2,5. This means at x equal to 2,5, the distance between the two graphs will be at its furthest point. Did they ask me for the length of fg, the maximum length? No. If they did, you would have simply substituted the 2,5 back if they asked you for that. Again, I apologize for those of you that were writing divide by negative 2 and that, but I wanted to teach you a lesson. Hopefully it's lesson learned now. Ladies and gents, I'm going to quickly move over to the next question because I don't want to spend all my time just on this. Again, rewatch this if you are feeling a little bit stuck. If you are feeling a little bit, you are moving fast, sir. I apologize. I only have so much time. Let's quickly look at the next one. Now the next one, ladies and gentlemen, on the next slide looks like this. Now I love this question simply because now all of a sudden it mixes exponential graphs with parabolas. Not seen often, but this was a beautiful question that came out in a previous exam that we set up. So I'm going to look through this. Now, I adjusted this question a little bit to make it a bit more interesting. Actually, also to make it easier, because the original question was also determine fx. Now, I'm not going to do that again, but it's a worthwhile exercise for you to see how can I determine f of x's equation, or sorry, g of x's equation. My apologies. Because the interesting thing is I need either the x-intercepts or the turning point. Now, interestingly enough, with the turning point has got two interesting things in this case. First of all, it has the same y value as the asymptote. Secondly, it passes through the x-intercept of f of x. So let me, before we start anything, let's analyze f of x. Now, how do I analyze f of x? Well, f of x, first of all, okay, that negative in front of the x, the 3 to the x, means that it lies under my asymptote. The 3, because it is bigger than 1, it goes away from the asymptote. So it makes sense. Okay? Oh, let me leave that one there. And then lastly, the plus 9 is the asymptote. Oh, but that's fantastic, because that then is the turning point of my parabola. Fantastic. The y value. I would still like the x value of your turning point, but let's quickly look at the first question. The first question asks us, determine the lengths of OA and OB. So A is the y-intercept. So let's start with that one. Let's start with OA. Let's do the y-intercept. So it's going to be f of 0, which is negative 3 to the naught plus 9. Please, ladies and gents, at this moment of time, you bring that calculator in, especially in an exam. When you're doing it at home, try and do it without use of a calculator. But in an exam, please bring in your calculator just to make double sure. That answer is 8. So in other words, always answer the question, OA is 8 units. Now, let's go on to OB. OB is the x-intercept. So in other words, I'm going to make f of x equal to 0. So I'm going to say 0 equal to negative 3 to the x plus 9. Now I'm going to try and solve it. Remember now, here's the important thing. You need to be able to solve exponential equations. If you're a little bit rusty about that, on the Junior Tucky channel, there is a video under algebra and equations about how to solve exponential and surd equations. Please go and check out that video if you're a bit rusty on how to solve exponentials. Well, in a nutshell, you have to get your power alone. So the 3 to the x. So I'm going to take it to the other side. So it's going to become positive 3 to the x equal to 9. Then make the bases the same, and therefore we equate the exponents because the bases are the same. So in other words, OB is 2 units. Interestingly, ladies and gentlemen, let's go back to the sketch. A is at 8 and B is at 2. Oh my good golly gosh. I've got C's coordinates. X is 2, Y is 9. Fantastic. So therefore, if they ask me to determine the equation of the parabola, I could actually do it now because I've got the turning point and I have D's coordinates. So I could do it. So please, in your own time, go and make sure that you are able to determine the equation for g of x. Let's quickly have a look at the B question. The B question. The range of f. In other words, y is an element of, and I like to always say to my students, minimum to maximum. So I've got two mountains that's standing in front of the monkey. If you don't know what I'm talking about, again, go and watch those videos on mathematical reasoning under the Junior Taki channel. I know I'm doing some advertisement for my videos, but it's there to help you. There's a wonderful series of videos about mathematical reasoning and how to solve problems. And I talk at length about the monkey behind the mountains, the monkey being your end problem, the mountains, what's standing in your way of solving it. In this case, the monkey is the range, but the mountains is the minimum and the maximum. If I look at my graph of f, there's no minimum. It just, the y value goes down and 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 down. There's no minimum. So in other words, my range is negative infinity. The maximum, what is the highest value that my graph can be? Well, it's never going to go higher than my asymptote, so 9. Now here's the thing. Will it ever touch infinity? No, not really, because infinity is not a number. It's a beautiful concept. If you don't understand that, please ask your math teacher to explain it. It is beautiful. It's interesting, and it's gonna be a complete boggling of your mind, but it is beautiful. Will it ever touch the asymptote? No. I just want to quickly hit the pause button with you. Okay, I'm going to switch over to full video mode for this. Ladies and gentlemen, I just want to quickly talk about asymptotes just for a little while. One of the biggest misconceptions among my school students, my scholars, are that a graph can never cross an asymptote. Unfortunately, that's not the truth. I know a lot of teachers explain it that way. And the reason why they explain it that way is simply because it's a very difficult concept for a grade 10 learner to actually understand. There will be, at varsity level, there will be actually graphs that do cross horizontal or oblique. That means like skew asymptote. There will be graphs that cross it. But a vertical asymptote is not crossed. But now here comes the thing. So it's not that your teacher lied to you. It was just they made it easier for you to understand. I just want to quickly tell you a way that I like to think about asymptotes. I like to think about asymptotes as if they are electrical fences. Can you cross an electrical fence? If you try hard enough, yes. But will 99% of the population cross an electrical fence? Try and climb over? No. Are there some people that do climb over electrical fences? Yes. So in a nutshell, core maths, your graphs will never cross an asymptote until you get to varsity. AP Maths, guys, be prepared. In Matric AP Maths, there will be graphs that do cross asymptotes. I've warned you, look out for it. So remember those electrical fences. Now, because I am working with an exponential graph, it will never cross my asymptote. Now, let me quickly go back to my sketch. Let's look at the rest of this question. The rest of this question now says, okay, and for this question, I am going to actually go over to a new sketch. I'm going to kind of erase my sketch and move over to a new slide so I can answer questions D, E, and F. If I look at questions like questions D, E, and F, now I am saying this as a kind of a disclaimer. They are meant for the 80s and 90%ers, but please do not let that throw you off if you are a 50 or 60%er, because maybe, just maybe, you will get it. So look at what I'm doing and try and do the same. If they look at f of x times by g of x greater or equal to 0, that means the y value of f times by the y value of g must be positive. Let me repeat that. The y values of f times by the y values of g must be positive. If I look at a sum like this, I am now going to analyze f by using red and g by using green. If I look at f, I'm going in red. Okay, that is my exponential graph. My exponential graph is positive, positive, positive. The y values are positive, positive, all the way up to point B. Then it becomes negative and it stays negative ad infinitum. So forever and ever and ever it continues going more negative. But now if I look at g of x, my graph starts off being negative all the way up to that point there. Then my graph, my y values become positive. All the way, whoa, that one didn't come out right. All the way up to that x value. Then my graph swaps to being negative again. Okay. So now I'm going to quickly ask myself, how do I get a positive answer? Well, I could have a positive times by a positive or a negative times by a negative. So I'm going to look at where do I have a positive and a positive at the same time, or a negative and a negative at the same time. Let's start on the left of the x-intercept, the first one. Here I have, on this side, I have a negative times by a positive. I don't want that. Then I have a positive. So in between these two sections, I have a positive times by a positive. Yes, I want that. Then on between those two areas, I have a positive times by negative. Don't want that. And lastly, remember here my y values are very negative for the greens. So on the right-hand side of that x-intercept, I have a negative times by negative. So it's a positive. Fantastic. But a bit of an issue. I don't have the x-intercepts of the parabola. Oh, sir, look at the mark allocation. 6 marks. That means I am not going to just be able to write down the answers because I need the x-intercepts of the parabola. So I'm going to, first of all, have to get the x-intercepts. So if I get the x-intercepts, so 0 equal to negative x squared plus 4x plus 5. So in other words, x squared plus 4x, minus 4x plus 5 equal to 0. Oh, Sorrel, what are you doing? That must be a negative. You see, if I'm in a hurry, I even make mistakes. Don't be so hard on yourself if you make a mistake if you're in a hurry. But always be willing to correct yourself. So I've got x equal to 5 and all x equal to negative 1. Let's go to my sketch 5 and negative 1. Remember, we have 2 from the previous slide where we got b's coordinates. So let's look at this first domain. So x between -1 and 2. Now here comes the thing. Did I say equal to? Yes, I did. So it does mean I can have equal to 0, and I can have equal to 0. Or this last domain, from 5 up to infinity, it's going to be a negative times by negative. So 5 it can touch, but never touch infinity. If there were no equal, so if they didn't say bigger or equal to 0, then it would not have been square brackets. It would have been round brackets because we can't have equal to 0. Woo! I'm having fun tonight. I hope you're having fun with me. Now let's quickly look at questions E and F. I must just calm myself down. I still have a little bit of time before my hour is up with you. But let's quickly, before I get to E and F, I just quickly want to throw you kind of in the deep end. What if I change this one here and I say fx divided by gx greater or equal to 0? And now my grade 11 students freak out. So now divide. Please just relax. How do I get something divided by something else to be a positive answer? Exactly the same if I multiply them. So in other words, a positive over a positive, or a negative divided by a negative. Oh, but wait, sir. Do you mean that it's where both graphs are positive and both graphs are negative? Yes. But haven't we answered this already, where both graphs are positive or where both graphs are negative? Yes. So is the answer exactly the same as the previous one? No. I was leading you on there. I'm going to say hashtag sorry, not sorry. There is one difference, and this you've got to look out for. Because we are dividing, I have a restriction. My restriction is that I'm not allowed to divide by 0. So in other words, g of x may not be 0. So in other words, my parabola, the y values are not allowed to be 0. So in other words, x may not be -1 or 5, because that's where g of x is equal to 0. So now how would this look? Well, I would still go from -5 up to 2, but now it can't be -1, but it can still equal 2. Or from 5 up to infinity. Again, x can't be 5 and it can't be infinity. Lack of catch-out question that, ladies and gents. Woo, this is starting to become a fun evening. Not fun if you see it in the exam, but now at least you know how to do it. Have courage, young Padawan. Stick with me. Let's have a look now at E and F. If I look at a question like question E, I'm going to do it in this little block here. They are asking me, how did I transform fx, let's just write it down, through -3 to the power of x plus 9. How did I transform this into y equal to -1/3 to the x plus 2? Huh? Okay, whoa, so, whoa. Ladies and gents, let me quickly share this. Very important. You need to have the two graphs looking as much alike as you can. The +2 at the back is not my issue. But what my issue is, the 3 that changed to a third. So let's rather change this back. Now, 1/3 is 3 to the negative 1. So in other words, actually, 1/3 to the x is actually 3 to the negative x. If you are unsure about this, remember, 1/3 is equal to 3 to the negative 1. Now the question is, let's start. How did I get an x and change it into a negative x? What kind of a transformation changes x's into negative x? Well, that's a reflection in the y-axis. Oh, fantastic. So it was a reflection in the y-axis. That is the first thing that happened. Now, secondly, how did I get the 9 to go to 2? Well, I just subtracted 7. So plus 7's units down. I'm just going to write this. I translated 7 units down. That's all that I did. So first of all, your approach is try and make the thing that they give you look as much like the original function that was given. Then you look at reflections, x changing to negative x. Or reflection in the x-axis means my whole function becomes negative. So I put a negative in front of the whole function. Then you look at shifting up or down, left or right. Oh, this is fantastic. This is great. Now, just a little bit of a heads up. Next week, I'm going to be doing another live session. But this live session will be about trigonometry. And in this live session, I'm going to ask you to tune in because I'm going to be handling trig graphs. In there, I will be looking at left and right translations in a lot more detail than I am today, just for the sake of time. Let me quickly look at question F. Now, for question F, ladies and gents, I am just going to make my graph just a bit cleaner. So I'm going to erase everything that I wrote down to explain to you how I would do F. The moment they ask me g of x equal to k, what I like to do, and you can watch one of my other videos as well, I love to do that. I like to split this thing up into two things. Y equal to g of x, that's just a function of g of x, and y equal to k, which is a horizontal line. Let me not do dashed lines. There we go. Now the question asks, where is g of x equal to k? Now, the moment that I split it up, I'm talking about two different equations. A parabola, which is sketched, but also y equal to k, which is a horizontal line. So let me draw in y. Ooh, that's not horizontal at all. Y equal to k. So they are asking me, where is g of x? So my parabola, let me do it in red, equal to y equal to k, but they're asking you no real roots. In other words, no intersections. Oh, what did I do there? Oh, there we are back. Sorry about that. No intersections. In other words, where will the red graph and my purple drawn graph never intersect? For what values of k will my, and remember k is that value there, let me do it in purple. Where will these graphs never intersect? Well, if I draw it exactly on C, then it intersects once. But anything above C, there will be no intersections. Now, if I draw this line on C, then K is 9. So in other words, any value above 9, there won't be an intersection between the purple graph and the red graph. Well, then that's my answer. Really, sir? Yes, that's my answer. Because I don't want intersections. So therefore, for k bigger than 9, there'll be no intersections. What about if, and I'm just going to do this here quickly, what if k is equal to 9? Well, then there is one intersection. What if k is smaller than 9? Well, that is like the first one drawn. Then there are two intersections. I know this is weird. That's why it's also meant for the 80s and 90%. So very simple. Whenever they give me g of x equal to k, personally I look at the intersection between two graphs, my normal drawn graph, and then as well I look at where the graphs intersect once, next year maybe 3 times when we do cubics. So let me quickly move on to a last little question. Just for those of you that love hyperbolas and you cannot bear to think of not doing hyperbolas, you don't have to have some FOMO. Here is a beautiful little question about hyperbolas. Given that k of x is equal to a over x minus p plus q, draw a rough sketch of if a is smaller than 0. Okay, great. Woo, let's quickly stop there. If a is smaller than 0, let's start there. Oh, I love these questions. I just have to say I get excited about that. If a is smaller than 0, I know my graph lies in quadrants 2 and quadrants 4. Okay, that's that I know. Oh my goodness. P is greater than negative A. Okay, let's put that one on the ice. I'm gonna just wait with that one, please. So wait. Let's start with just the easy things that I do know. Q, let me do it in a different color. Not purple, but red. Red. If Q is smaller than 0, I know if there's my X and my Y, I know that my graph, my y-intercept is going to lie like that. Now I've got to ask myself, what is P all about? Now if I look at this equation, P is the vertical asymptote. So in other words, it will determine where my graph has a vertical asymptote. Here's a little bit of a nice thing that I would like you to do. For those of us that's not getting 95 and above, okay, that's pretty much the majority of us. What I would like you to do for yourself, don't show this to the examiner, is pick a value that satisfies the initial A value. They tell me that A is smaller than 0. So let's, for instance, say that A is negative 2. Okay, let's make A negative 2. Let me just write it nicely. Negative 2. Now they tell me P must be smaller than negative a. So in other words, p must be smaller than negative 2. So in other words, p must be smaller than 2. Okay? Now if p is smaller than 2, okay, I've got to now kind of look at my graph, okay, look at where this means that if I substitute this in, f of x equal to k over x minus, now it could be any value smaller than 2. So it could be, for instance, 1. I'm choosing, now you will see what I'm doing here. This is a nasty little sum. I'm going to split this up into 2. You'll see now why I do this. I'm going to pick a p-value that lies between 0 and 2. So still positive. So let me pick 1, for example. For example, p is equal to 1. Okay, therefore, my x asymptote, now I'm not concerned much about the actual value, and if you want, let's just do the plus q there. I'm not concerned about that. But it means my asymptote lies on the positive side by x equal to 1. So in other words, a possibility for my sketch is if x is equal to some kind of value, my graph, because q is smaller than 0, it lies there. My graph could lie there or there. Let me just extend my y and my x. There is one possibility. Now for the examiner, you won't write the x equal to 1. You just say x equal to p. But now what if, scenario 2, what if p becomes smaller than 0? For example, what if p is equal to negative 1? Well, then my graph would look like y equal to k over x minus negative 1 plus q. So k over x plus 1 plus q. Now, all of a sudden, if there's my x and my y axis, my x asymptote lies on the negative side. So x is equal to negative 1. My q value is still negative, y equal to q, and my equation lies in quadrants 2 and quadrants 4. There we go. So in other words, I have possibility 1 as well as possibility 2. I know this is a bit of a doozy. I know it, ladies and gents. But that's why I'm doing it with you. So that if you get this in the exam, you can kind of see how to approach a sum like this. If you are struggling with mathematics, if there's really some stuff that you are feeling, so, I would really love you to do this or that or do this kind of question, please feel free to email us. In the description, I'm going to place a Gmail account, juniortiki55@gmail.com. please email your questions to me, and I will gladly assist you. If it's a really awesome question that I haven't seen before, or I would like everyone to see, I will gladly make a discussion video and post it on the Junior Tucky YouTube channel. Please remember to subscribe. Hit that bell, the notification button, to get all the newest and latest videos we are going to post. Please remember, next week I'm going to cover trigonometry. I'm going to do some awesome trigonometrical sums, including trigonometric graphs. Ladies and gentlemen, it has been an awesome and wonderful pleasure spending some time with you in the comfort of your home or your boarding house. Who knows? Ladies and gents, keep well. This is Mr. VG signing out. Have a great and amazing rest of your day. Remember, you can do this. Keep well. Cheers.